time. What does it mean? With every tick of the clock, we move 1 second forward in time. With each breath we take, with the passage of every moment, we make new memories along the timeline of our life, while moving forward along the timeline at a finite rate, what we derive as the passage of time as we feel. But do we have to? Can't we just move forward in time at a different rate? Or else are we destined to always move forward in time? Why can't we move backwards? So that we can be in our most precious moments in the past once again. If that's possible, do we get the ability to break the basic principles of causality then? What's the difference between the past, present, and the future? Are you confused with all of these questions? Well, then are you ready to have a closer look? First of all, what is time? According to Isaac Newton, time is absolute. If time is absolute, we should have a universal tick-tock that governs the time for every entity in the universe. But do we have that kind of universal clock? Well, according to Albert Einstein, the answer is no. His theories of relativity suggest that the time is not absolute, but rather it's relative, and that time is not any special phenomenon, but rather one of the 4 dimensions of what is called space-time, which is the single fabric that consists of space and also time within it. We all are moving in space-time at the speed of light even right now. According to his theory of special relativity, the more we travel through space, the less we travel through time. The less we travel through space, the more we travel through time. This can be simply demonstrated by a graph like this. However, at any time, we cannot exceed the speed of light. In other words, according to the theories of relativity, the speed of light acts as the universal speed limit. When we accelerate an object more and more to achieve higher and higher speeds, the mass of the object increases, thus acquiring more energy to accelerate. Thus, to accelerate to achieve the speed of light, an infinite amount of energy is required, thus making it practically impossible as we know it. However, when we move at speeds closer and closer to the speed of light relative to a certain observer, the time begins to move slower and slower for us relative to that observer. That means, for example, if someone traveled at 99.99 the speed of light on a spaceship and returned to Earth in 10 days, nearly 2 years would have gone past on the Earth relative to him. This effect has been experimentally proven. The International Space Station is moving really fast relative to the Earth. As a result, the astronauts in the International Space Station are traveling 10 microseconds to the future relative to the Earth for every 1 year. This is one way of traveling to the future. However, to time travel in a considerable scale using this method, you need to have a spaceship which can travel insanely fast. But if you don't have that kind of spaceship, don't be sad, let's consider another option. According to the theory of general relativity, huge masses distort the space-time around it in a way that time slows down for us when we go near it relative to an observer farther from them. For example, time flows slower on the surface of the Earth relative to an astronaut in space. That means, if we spend several hours in a strong gravitational field near a massive object such as a black hole, several years would have been passed on Earth. This incident has been depicted in the movie Interstellar. However, you don't want to go near a black hole to experience this phenomenon. If you stand up for a minute, your head would be aged nearly 10 femtoseconds more than your feet. Wait a minute, but I previously said that the International Space Station and also satellites time travel to the future relative to the Earth. But they are positioned at a considerable distance from the Earth. So, don't they have the effects of gravitational time dilation? The answer is yes, it has. But however, for this particular incident, the effect of gravitational time dilation is relatively smaller than the time dilation due to the relative speed. So, is it a good option to go near a massive object like a black hole to do time travel? Well, whatever happens when you get there, it would be a really big challenge to go near that kind of object for sure. So, don't we have any other options? Well, there are some other options too. One option is really slow down your metabolic activities to the point that you are completely unconscious, and after many years using science you can be awakened and regain your consciousness, and to skip these years in between. In fact, some microorganisms such as bacteria are already doing that. Even some animals such as bears, squirrels, and bats follow a similar short-term strategy known as hibernation. However, this is not an actual physical approach toward the time travel, but rather it just gives a sensation of skipping time through a biological approach. If you hate sleeping for a really long time, then you can consider some other options too. Let's think of a worm on an apple for a bit. The worm needs to get to the other side of the apple. So it crawls around the apple and gets to the other side, as you might think. But is it the only way possible? If that worm is smart, it can eat through the apple and get to the other side in a relatively shorter distance and time. This concept is actually named as wormholes. This can be true for our four-dimensional universe too. We may be able to create shortcuts in the four-dimensional space-time that connects 2 points in the universe that are very distant as they seem in 3 dimensions. Or else, we can connect 2 points in time, the present with a point in the future or even in the past. This type of portal is known as an Einstein-Rosen bridge. Using this kind of portal, we may be able to travel to any point in the future or past within a very short period of time. However, for now, even if we create one, it's a really big challenge to keep that kind of portal open for a considerable time. For that, it needs large amount of antimatter and negative energy, which we haven't understood fully just yet. Another time travel idea is to use a rotating cylinder of light to twist space-time. Anything dropped inside the cylinder would theoretically be dragged along the space-time. According to this theory, with the right geometry, you could time travel into the future and the past. However, this idea is quite recent and not been grabbed by many people. Anyways, in conclusion, the concept of time travel using modern science is fairly new, and therefore being not practical right now doesn't mean that it wouldn't be practical and common in the future. However, as we cannot do time travel right now, we cannot know it for sure either.